Let's find the solution to the Fibonacci recurrence relation. So what we'll do is first write it in standard linear form and recognize that it's second order. So we'll assume a solution of the form lambda to the power of n. And if we substitute this in our recurrence relation, we get lambda to the n minus lambda to the n minus 1 minus lambda to the n minus 2. And that's equal to 0. So from that, we can factor out lambda to the n minus 2. Then the first term in the brackets is lambda squared. And then we have minus lambda minus 1 is equal to 0. So this equation is satisfied when the characteristic equation is equal to 0. And if we solve this using the quadratic formula, we have lambda is minus 1 plus or minus the square root of minus 1 squared, which is 1, minus 4 by 1 by negative 1. And that's divided by 2 by 1. So therefore we get two roots, being lambda 1 is 1 plus root 5 on 2, and lambda 2 is 1 minus root 5 on 2. So our general solution is some constant by lambda 1 to the power of n plus another constant by lambda 2 to the n. And now we can apply our initial conditions. So we have S0 is equal to 1, and here S0 is a by this number to the power of 0 plus b by this number to the power of 0. So we get a plus b. And similarly S1 is equal to 1, so that's equal to a by 1 plus root 5 on 2 to the power of 1 plus b by 1 minus root 5 on 2 to the power of 1. And from this equation, you get b is 1 minus a, which you can then substitute into this equation. And if you do a bit of algebra and solve for a, you'd get 1 plus root 5 on 2 root 5. And if you substitute this a into this equation, you'll obtain b, which will give you root 5 minus 1 on 2 root 5. And therefore this is our particular solution to the Fibonacci recurrence relation with the following values for constants a and b. Please subscribe, like and comment to help me reach more students.